Howdy everybody out there. This is a new video on this amplifier, which I've never done a video on. This is a Kicker ZR240 old school unit. Since I can't do anything about the Rockford right now because I have to get approval from the original owner, but this is the bare minimum of what it needs. And if I get an approval, we'll go through it. We'll do a repair video and you'll see all that. Otherwise, you'll never see another video on it ever again, sadly. But that's the reality of doing bench work when you don't know whether it's going to get repaired or not, because this guy that owns these work at a flea market and he's got to be able to make his money on it and I've got to be able to make mine. So anyways, now that we got that out of the way, we're going to go ahead and look at this one. So this will be the next video in the series of repairing this thing, or well, this series of repairing these amplifiers. So these were fairly popular for a time period. Well, no surprise there, it's missing screws, so this one's been molested and, you know, gotten into, and I'm destroying my table. And unfortunately this table's not mine, it's the landlord's. So yeah, I'm gonna have to do something about that. So I've got 2 screws. Wow, two screws. And my phone is not, the autofocus on this phone is starting to break down. I don't know why. Seems like you only get a year or 2 out of a phone anymore before they're junk. Sadly. Welcome to reality. Alright, let's pop this cover off and see what we got. Well, first thing I'll do is look in the bottom of the cover and look for explosions. Don't see any. Okay. So, let's move that out of the way and let's do another inspection. Alright. I've seen the solder joints break on these. This is that chip thing that Kicker came out with for a while. I'm kind of glad it disappeared, because these things were a nuisance and they would break right here at the solder joints. So that's one problem these things had. The other problem these things had was the output section would short. So again, as the previous video, sight, sound, smell. It doesn't smell bad, but I can already see right away we've got some problems, especially in this channel over here. That means the amplifier was mounted on the speaker box, so that circuit board would have been upside down and the resistor came out of its solder joint. And why did that happen? It's because it got blistering hot. Why did it get blistering hot? Well, probably because it's shorted. The transistor that's connected to is shorted. See, we've got that resistor there, which is fried. I don't know what value that is. How do you determine what value that is? Well, I'll tell you how. You look at the adjacent channel, that's good. And this would be a 22 ohm resistor. I don't think that's the same channel or the same resistor. No, it's connected. Nope. It could be this one here. 10 ohms. Yeah, it makes sense because they're connected to the base. So that's a 10 ohm resistor. If you look at this one, it also is connected to the base. And yeah, those 2 transistors are connected here. So since this fell out, and that is blown to smithereens, you can pretty much safely assume that that transistor is shorted, because we're taking rail voltage straight to ground, or straight into the speaker, which is going to destroy the speaker. So let's go ahead and make sure that this thing is dead. I'm pretty sure it is. So we'll grab our meter probes. Of course, I sat the stupid lid right on the damn probes. I would do that, wouldn't I? So, alright. Let's go ahead and meter to here. Since I can't get the probes over one-handed, I'll go over here because they're connected in parallel. Nope, that transistor's good, which is, that one's not so much. Alright, so we've got that. Alright, let's see. We know that since this resistor is out of the circuit, this pin is not connected anywhere. So all I got to do is meter it between here and collector, which the collectors should be in parallel because of the way it's designed. It's a Class B or AB amp. Okay, those two are definitely in parallel, like I said. So let's measure that one. Yep, that transistor is definitely shorted. So let's go across here just to see if I can do it. Yep, I can. Definitely bad. Alright, that one's good. And so is that one. So we've got one bad transistor right here for certain. And that's fairly evident based on which parts burned up. And that's a good step in troubleshooting is sight. We don't have sound because we're not powered up, but we're using the sight and smell. The smell is pungent. If you know what the magic smoke smells like in electronics, you know what I'm talking about. And then once I saw this, I know that it's damaged. There's damage in that circuit. So since this is a Class AB amplifier, you have three main stages. You have the differential input stage, which could be an op amp or it could be a pair of transistors set up in a current mirror configuration. You have the VAS, or the voltage amplification stage, which is in the middle. You also have the driver stage, which is these two transistors here, and this is what sets up your bias as well. See, this transistor and this transistor form the voltage amplification stage. This transistor and this transistor form the driver stage, and then the four big transistors form the output stage. And this is your bias adjustment. And for those of you that don't know, biasing on a Class AB amplifier, what that means is it turns these power transistors on ever so slightly together. So there is some quiescent current leakage between the rails. Okay, and the amount of that is set through this potentiometer. And the reason why you need that is because as a sinusoidal waveform is traveling like this, well, it starts at 0 volts and it rises, which means one half of this amplifier is turned on and the other half is turned off. And then as it falls below, it hits the 0 point and then crosses over, which means it hits a point to where these transistors are transitioning off while these are transitioning more on. So it gets more negative. Well, that 0 point is called crossover. And if these two let's say if this transistor switches off entirely and this one switches on, if you zoom into your sine wave, it won't look like a smooth fall. It'll stop at the 0 point and then be flat for approximately 0.7 volts, which is what it takes to turn these on, and it'll start falling again. That's called crossover distortion. So to minimize crossover distortion, which if you want to, you can navigate to Dave Jones' EEV blog and some other channels that explain this in better detail, but to minimize crossover distortion, that's what this biasing circuit does. And this is the temperature compensation transistor. This resistor turns this transistor on and off more, which allows current to flow between here and here continuously. Well, as the heatsink gets hotter, these transistors want to conduct more, okay? Well, so does this one. And as this one conducts from the heat, it tracks the outputs. So this will conduct more, which will cut off the bias, so it's not driving these as hard. It keeps it consistent. But the fact that there is current draw in an idle state to minimize crossover distortion is why these amplifiers are terribly inefficient even when idle. So anyways, back on target here. Since these transistors here probably form the current mirror / differential amplifier, here's your pre-driver, your voltage amplification stage, aka pre-drivers, your main drivers, and then your outputs. So we know for a fact, without a doubt, that this transistor is damaged. So let's check its complement, okay? That's not good either. Its complement is also damaged. Although, I've got 23 ohms. So that transistor is probably not damaged. However, the one next to it might be. No, it is not damaged either. So what I can do is I can actually go across this 10 ohm resistor here, because this will lower the impedance. Okay. It is 25, 24. If I go on the other side, fucking probes, 23.2. So, it's possible one of these guys are damaged too. And to be honest, if I want this amplifier to last, I want to do a better repair. And so I'm going to replace all of the output transistors anyway, just because. So here's what I'm going to do. To rule out that those transistors are bad, I'm changing them anyway, but just to make sure that they're not bad, first thing I'm going to do is I'm going to cut the base lead. This is base, collector, emitter. So what I want to do is I want to cut the base lead from the boards. So now that these guys, the bases are no longer in circuit. So now what I'm going to do is see if any of them are shorted. So I'm going to check the first one. Nope, not shorted. So I'm going to check this one. As soon as I can get my probes positioned to where I can actually use them, I'll be getting somewhere. Nope, it's not shorted. But the driver might be. Okay. Now, since we know without a doubt that this transistor is shorted, so we're going to go ahead and cut it completely out of the circuit. That way I'm not getting any false readings. So I know for a fact that one's dead. So I'm going to remove it from the circuit. And again, I'm going to take a reading from the circuit board itself and not the transistor. I can take a reading of the transistor. Tell you right now it's dead. It is. So it's now just a piece of wire. And what causes it to be a piece of wire is the molten die. It's molten and it's just carbon tracked. Okay, so I'm not reading any shorts in the board. So the next thing you got to pay attention to when troubleshooting these, when you've got damaged output transistors, it's usually the load that causes it, you know, shorting speaker wires or whatnot. But you also want to make sure that when the failure occurred that it didn't damage your drivers. Most people change them out of precaution, and that driver's definitely dead. 100 ohms between it, base, and emitter. So I know I've got damaged drivers. So what I'm going to do is try to measure it. Again, I have to hold the probe with my other hand because they're too close together. I do not have a tripod, sorry guys. This is why I don't do troubleshooting videos that much. Okay, so collector and base is not bad. So let's go over here to this one, to its complement. Got the same 100 ohms. Now, what I want to do, just to make positively sure, is I'm going to measure this side and make sure, see if I'm getting the same 100 ohms, because it might be normal in this design, I can't remember. Because this side appears not to be damaged. Yep, it's the same 100 ohms. So there's a 100 ohm resistor somewhere. Which makes sense, because if I look at R27, I think that's a precision 100 ohms. So same thing over here. If I have a precision, yep, got a precision resistor there of 100 ohms. So that means if I meter across that resistor, which easy way to do that would be between here and here, 100 ohms. So To genuinely test these drivers, I'd have to remove them from circuit, which I'm probably going to do that anyway, but I'm not going to get that on video. The point of it is, we've done a troubleshooting of one of the two channels, and this one's damaged for sure. This one appears to be okay, although I didn't physically test it. Most of the time, you lose the one channel, you don't lose them both at the same time. It's really rare that you do. The next thing I had to do is check the power supply stage, which I want to do that right now. Because if the MOSFETs are bad, we would have a short across here, and we don't. So I want to check the base, or I mean the source to ground, no short. Source to collector, I mean gate to collector, shit. Gate to drain, I keep getting confused. No short between gate and drain, and gate and source, no short there either. So this power supply section is likely okay, but the channel is definitely bad. And it was probably run that way for a long time, which is why this is burned up. Because if the power supply stage blew up, it would have probably blown up long before this guy burned up anyway. So that's another thing you'll learn. Tips of the trade, tips of the trade. So, yep, that's what we have. Not to mention people pushing out fuse holders and, you know, dumb shit like that. Very common, very common. Hey, the fuse blew. Let's just whack a bigger fuse in it. That's good, right? No, 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 no. Not really. I see that often. Yep. All right. Well, thank you for watching. This is a quick overview troubleshooting of the Kicker ZR240 power amplifier. Again, I'll quote it, and if I get an okay on the repair, you'll see the repair and test of it. Thank you for watching. Moving on to the next one.